Okay, welcome to Swell Academy today. Mr. Math showing you some equations with variables on both sides. Basically, the idea here is that now you're solving for an x or a variable, right? And solving for a variable, we're looking for a number that would fit into x that would satisfy this, where if I plugged it in, this would be equal to this. The biggest advice I give here is you always want to get x's together. You always want to work with them first, and you want to keep them positive. So we want to keep x positive. We want to get them together, get the x's together. And a lot of times what you could use to help you kind of remind yourself how to do a problem is you give yourself something funny. So I call this Miltos, move letters to one side. Now if you look, I can move my x to the left by an inverse operation. So I could subtract x, or I can subtract the 2x and move it to the right. I'm going to move my x to the left because, like I said, I want to intend to keep x positive. So we'll subtract the x from both sides, and if you see the 2x minus the x leaves me just with an x, and these two cancel out, and I've moved it from one side of the equation to the other. Now remember, the equal sign is what provides you with these sides that we're talking about, left and right sides of an equation. And you're left with x minus 8 is equal to 10. The other thing I do to remind myself is I call this motto. I pretend like this number sign is a 0, right? Move numbers to the other. So if I move my x's to the left, now I want to move my numbers to the right. And again, in order to do that, I'll have to use some inverse operation. And if this is a minus 8, the opposite of this will be a plus 8. And what I do to one side, I do the other. X is equal to 18. And if you see, if I plug this in, it's always great to check. You always want to check your work, right? I don't know how good of a check mark that is. You always want to check your work. And to do that, I would do 2 times 18. I'm plugging in this value I found for x, in for x, minus 8 equals x plus 10. And if I get the, 36 minus 8, now what I do to multiply 2 times 18, I like to do 2 times 10 and then 2 times 8. And that gives me 20 and 16. Put those together and you get 36. That's where your 18 comes into play. Oh, we want to plug in an 18 for this too. So the 18 plus 10, and I get 28 equal to 28. Another good question to look at when solving for this, because remember, we're keeping in mind we're keeping x positive, is a scenario where what happens if, or just kind of how do I move an x and keep it positive? So in this case, the last problem, remember, we moved the x to one side by subtracting the x, and we moved it to the side where there was more x's. But actually the strategy here dealing with these x's is not so much where there are more x's, it's again keeping it positive, but the idea that, well, I know this is negative 3x, so in order to move this, I'm going to have to add 3x. And then that 3x to one side is going to be applied to the 3x on the other here. And basically, in this case, we didn't subtract from a bigger amount of x's. We added to get rid of a negative x to keep our x's positive here. And we get 6 is equal to 4x plus 10. And then again, you move your letters to one side. So remember, last problem we moved to the left, this time we moved to the right. So now we're going to move our numbers to the left by subtracting 10 from both sides. And you get negative 4 is equal to 4x. And just simply, most of the time when you are, finished moving your letters to one side, your numbers, you're just ended up with a one-step algebra problem. Remember, a variable next to a letter is multiplication, so inverse operation, division. Negative divided by a positive is a negative, and here we get negative 1. And again, you could check your work. I also like to show you guys a problem in which you can kind of solve this, or how can I say, you can move your numbers and letters in one row and one set of columns, where I don't have to move my letters and then rewrite the equation. And then you can, once you through practice get a little bit better with this, you can start to say, okay, and I like this question I'm showing you guys because they're both negative. So there is some thought process. Okay, if I move the 10 this way, if I move which one's going to keep x positive? Well, keep in mind, just like the last problem, if you have a bigger negative number, the inverse is going to force you to add a bigger number. So the idea here is that adding the 10x is what's going to keep x positive. But instead of rewriting this, what you could do is just simply, you see the arrow going to the left, point this other number going to the right, and then you can add your 10 to the other side. Remember, when you're doing this, keeping like terms. So we added 10 on one side, we had to add the other. This row is created through like terms. These are like terms. I can't put the 10 here because the 10 is not an x. And then what you'll see is these will actually cancel out here. These will cancel out here. Again, we have a row of like terms here. Negative 5x plus 10x, that's what gives us our 5x is equal to 30, and we want to solve x is equal to 6, right? So, what are we doing here? Again, keeping x positive. And most of the time, if x's are on both sides, you're always going to be able to move them and get x positive. You're always going to be able to do that. But there is one case in which I want to show you guys where you're actually, going to have to make a decision whether to keep x positive and this is what I'll show you guys here. Let's say we had a problem where you have 2x is equal to x minus 8. Actually, I want to make this a negative 2x, right? Now here is a little bit different because yes, our variables are on both sides, but our numbers are already on one side. So what do we want to do here? Do we want to keep x positive? Or do we want to just get our x's together and not have to worry about moving and move the number in order to do that? So let's just take a look at both ways. One way, I'm going to try to keep x positive and say, okay, I'm going to move my 2x to this side by adding 2x to both sides, right? So I get 0 is equal to, now don't forget there's a 1 in front of the x here, 1x plus 2x, that's where the 3x comes in, okay? And then I would move my numbers to the other. That's one way you could do this. You could move things in a way that gets x together, and then you end up with 8 is equal to 3x divided by 3, x is equal to 8 thirds. I probably would want to use a 9 here next time just to show you guys what whole numbers, but it's okay to throw in a fraction. And then, you could also look at this problem, moving the x the other way, in which it would limit your steps, where meaning you wouldn't have to move this number and just say, okay, let me just scrap keeping x positive. Maybe in this case I could solve this problem where x is a negative by just moving my letter to the left and then dividing both sides by -3. And don't forget, a negative and a negative is a positive, so I end up with the same answer. But I've done it two different ways. One just by getting x together, and then the other by, keeping x positive. I kept x positive and I got things together. And then you could come up with your own, don't forget, you could come up with your own Miltos motto, whatever it is that's going to help you remind yourself to move the letters first. That's a big thing, getting the letters first. Remember, the more you fail, more you succeed. Right? This is a balanced equation here. Equal amount of failure and succeeding. It'll happen, you know. You just keep practicing this and whatnot, and just continue working hard. Thanks for stopping by.